Hello everyone, this is week 6 Wednesday and it introduces the preemptive goal programming. So this method is used when there is no solution that will satisfy all of the goals, and in this case the decision maker must rank the goals in order of their importance, and it introduces variables rho I in the component of the deviation variables. So we use S sub I superscript minus for values that are lower than our anticipated value, and Si superscript plus for values that go over our desired goal. Uh, Having those in mind, then we solve the LP one goal at a time and use the result of this goal as a new constraint in the original LP and keep repeating this process until all the goals are met. So let's look at the first example. It is about an advertising agency with 10 employees that needs to make sure that they can reach their advertisement goals. So the first goal that we have is to minimize the exposure goal, which is 45,000 people, and the second one is to minimize the budget, which is $100,000. So we introduce all of the variables, and we will use 6 variables and 4 equations. So our variables will be x1, x2, and in total we can use x3, x4, x5, and x6. So let's plug this in total and see how it works. So we're gonna name our table top ad, and like I said, we have 6 variables and 4 constraints, and we're just gonna enter all those in. So we are minimizing G1, which in our case is also S1 superscript negative, which is also X3, and I'm just plugging in the rest of the constraints. Just in the order that they are on our paper. And solving for the first LP, we get the solution that we can do X1, which is the radio broadcasting, needs to be 5 minutes. The TV broadcasting needs to be 2.5 minutes, which is our X2. And with all the resources that we have given, we can be at 40 million people reached, or we're 5 million under our goal, because the G1, which is also S1 with the superscript negative, means that we're going to be under our first goal. So let me just make this a little bit bigger so you guys can see. Okay, so now that we have solved our first LP, we can take back that S1 superscript minus is equal to 5 and plug it back into the original equation with now 6 variables and 5 constraints. And right now we are minimizing G2, which is S2 superscript plus, or in our case, X4. I'm sorry, X6. So just spare me for a moment until I plug in the values and we get the result. And here is our solution. As you can see, the minimum value of G2 is 0, which means that we're still staying at the same 5 minutes of radio and 2.5 minutes of TV. So I'm just gonna type the optimal solution and I'm gonna explain it to you. So since S2 subscript plus is 0, that means that we did not go over budget. We stayed within our 100,000 budget, and we still are reaching 40 million people via the commercial while fulfilling the budget goal, doing 5 minutes of TV. I'm sorry, 5 minutes of radio and 2.5 minutes of TV commercial. We can also do this problem as rather than satisfying goals, just use it as an minimization optimization problem or a maximization optimization problem. So we're gonna use the first, maximize the viewers or the exposure subject to those two constraints, and we're gonna solve it in Torah. Let me just switch to Torah very quick. So let's call this top at question 2 or problem 2. And we have right now two variables, x1 and x2, and just two constraints. So right now we are maximizing P1, which is 4x1 plus 8x2. And right now I'm just gonna enter all the variables for the constraints. So solving the maximization problem, we found out that the maximum number of viewers we can reach is 40,000, and that is when we have 6 minutes of radio. I'm sorry, 0 minutes of radio and 5 minutes of TV commercial. So now we can use this data to minimize the cost using the new constraint. Let me just type in what our results are. So again, we're reaching 40 million people when we have only TV commercial for 5 minutes and no radio commercial. So let's go and see how much that's gonna cost us. So right now we're gonna try to minimize the cost based on the numbers that we just got. And we're gonna do this as optimization, linear programming, rather than satisfying goals by using the restraints we have and adding the new restraint that the exposure needs to be at least 40 million people. So plugging this into Torah, right now we still have the two variables, but we have three constraints because we already adding the constraint for exposure. And this is going to be P2, and now we'll need to minimize it. So let me just plug all those values in and see what we get for the answer. So now we got that the minimum cost would be 96,000, which is much better than the 10,000 we got before. And we can reach this when we have 6 minutes of radio, which is X1, and 2 minutes of TV commercials, which was our X2. So to plug this back in and answer the question is that optimal solution would be a minimum cost of 96 $1,000. I just wanted to make sure that it's in thousands. When we have 6 minutes of radio and 2 minutes of TV, and still we are reaching 40 million people. So this is all for this video, and watch the next video that solves another problem on the preemptive goal programming method. Thank you.